Hi class, Mrs. Calvi here. Quick review on angles and polygons. And before we even get to angles in different polygons, the first thing we need to talk about is what is a polygon. So a polygon is a two-dimensional figure, which means it's flat, okay? It is a closed figure and it has no curved lines, okay? So those are the criteria. There are three criteria to identify a polygon. So we are talking two-dimensional. So two-dimensional. It is a closed figure. And no curved lines. No curved lines. Okay? Now, the first polygon we're going to talk about is a triangle. Because if you think about it, a triangle is the first polygon because it is the one has the least amount of sides to have a closed figure, right? So, information that's important. All triangles, their angles total 180 degrees. So when you add up the interior angles of a triangle, it has to total 180 degrees. So here I have an equilateral triangle, which means all the sides are the same for an equilateral triangle, and all the angle measurements measure 60 degrees. Okay, so all of these angle measurements in an equilateral triangle are each 60 degrees. That will never change. All right, next I have this triangle. It's not an equilateral triangle. I have angle A, which is 60 degrees. It measures 60 degrees. So this angle right here, 60 degrees. I have angle B, which measures 40 degrees. And my angle C is unknown. That's what I need to figure out what the measurement is. So here, if you notice, I have 60 degrees is my angle A. I plug that in. I'm adding my angle B of 40 degrees. And I need to add something that will total 180 degrees because I know that all triangles, the three interior angles must total 180 degrees. So in order to figure out my missing piece, I'm going to take the 180 degrees, subtract the 60 degrees, subtract the 40 degrees, and I would be left with my angle C equaling 80 degrees. All right, pretty simple. So triangle is pretty much the basic of a polygon. We should know it's something that should just be known that all triangles, the interior angles, total 180 degrees. So now it's when we get into other polygons and we need to know what they measure. There's a little bit of a trick to that, and I'm going to show you that next. Okay, so before we find out how to figure out what the interior angles of other polygons measure, I want to tell you that we have regular polygons and we have irregular polygons. So regular polygons, all the sides are equal lengths and all the interior angles are equal. So for example, an equilateral triangle, right? So if I had an equilateral triangle, and you're going to pretend this is equilateral, all of my angle measurements are the same, which we now know they each measure 60 degrees. And all of these side lengths, so my side length here, all have the same measurement. So let's say if this were 3 centimeters, then this would have to be 3 centimeters and this would have to be 3 centimeters. All right. Now, irregular polygons is any polygon that is not regular. So if the interior angle measurements are not all the same and the side lengths are not all the same, it is not a regular polygon. It is considered an irregular polygon. Okay? Okay, so we know that a three-sided figure is a triangle and the total interior angle measurements measures 180 degrees. Now, I just happen to have a couple others listed. A four-sided figure is 360 degrees. A five-sided figure measures 540 degrees. And, a four-sided figure is a quadrilateral. A five-sided is a pentagon, and so on and so forth. Okay? And actually, a 10-sided is a decagon. You can't see it. It got cut off. Now, the question is how do we know that a four-sided figure measures 360 degrees? So if we start out with a three-sided figure, And we know that that is 180 degrees. Every time you add a side, you add 180 degrees. So if I took 180 and I added 180, that would give me 360. Now, if I knew that a four-sided figure measured 360 and I just added 180 to it, I would then get 540. Every time I add a side, I add 180 degrees. Well, let's just say you wanted to know what an 8-sided figure was. Well, you don't want to have to go through this whole process of starting out with a 3-sided figure, getting 180, adding 180 to get 360 to get the 4-side. It would take you quite a while to figure out, well, that an 8-sided figure, an octagon, their total measurement interior angles 1080 degrees. So there's a shortcut to that. So remember, these measurements are the total interior angle measurement for these polygons. All right, and these are regular polygons here. So now there's a formula for this. So the formula, my mouse keeps sticking, the formula to figure out what the total interior angle measurement is of a polygon is n minus 2 times 180. And n represents the number of sides. So let's say you needed to know what the interior angle measurements of an octagon is. An octagon is an 8-sided figure. So the number of sides would be 8. I would then subtract 2, multiply 180. If you notice, I have this in parentheses. Order of operations comes into play. We have to solve what's in parentheses first. So 8 minus 2 gives me 6. If I were to do 6 times 180, that would equal 1080 degrees. So this is the handy dandy formula that you would want to know to find out what the total interior sum of the polygons are. So that's the total interior sum of your angles. All right, and that is it for now, and I will talk to you guys soon.